Continuing on with Unit 3, the head and the spine, we're going to cover in this lecture the mesencephalon, to include the cerebral peduncles and the quadrigeminal plate or the tectal plate, the brainstem with the pons and medulla, and the cerebellum, to include the vermis, the left and right lobes of the cerebellum, the cerebellar peduncles, and the cerebellar tonsils as well. You're probably not surprised to find a midline view of the brain here from Netters. It's a great tool to use to study. You've got all of the structures that we have already studied in the upper portion of the brain, the cerebrum, the corpus callosum. We've got the third ventricle with the intrathalamic adhesion. We've got the infundibulum and the pituitary gland, the mammillary bodies, the cerebral peduncles, pons and the medulla, which we're going to study today, and the tectal plate, pineal gland here, and the posterior commissure, this cerebellum and the fourth ventricle and the obex. And we're going to study this area. This is also considered the posterior fossa, so I wanted to point that out to you. The area that is infratentorial, below the tentorium. Infratentorial is called the posterior fossa, and you might hear me refer to that as well as to the cerebellum along the way to here today. There are three other images within e-anatomy that help us to correlate the areas that we're talking about. Up in this upper left-hand corner here, the colored image has our diencephalon, which we've already studied with the pituitary gland and the infundibulum and the third ventricle and the intrathalamic adhesion. And then below that we have the mesencephalon, which includes the cerebral peduncles and the tectal plate. This is sort of in a darker blue, almost purplish color, not to be confused with the purple color here in the cerebellum. And then sort of in this medium blue we have the pons. And in this kind of a light green here, we have a myelencephalon, the medulla. And then we have the cerebellum here in the light and darker purple. And this image is also nice to correlate with this image down here on the right-hand corner. It's got some of the same coloring options, just breaking it down a little bit differently and magnifying it up a little bit so that all you're seeing is from the corpus callosum on down into the brainstem here. So that gives you just that mag view, and then even magged up a little bit more on the left-hand side here. You can see just the sylvian aqueduct, fourth ventricle, and then the obex, the opening into the central canal and the brainstem. We've got the cerebral peduncles, the pons, and the medulla, and then the cerebellum in the posterior section. So it's a magnification view that's just a little bit bigger than the other two, and it's a nice one to study from as well. So before we move on to the axial images in the brain, for this first section, I want to show you a little bit about the cerebral peduncles and the tectal plate here on this image. So we've got the cerebral peduncles here and the tectal plate, and between them is a sylvian fissure, and you'll see on the next images how very thin that is. That sylvian fissure, as it goes down in between the cerebral peduncles and the tectal plate, it almost seems like it's just a dot on the axial images. It's so thin. And the tectal plate, also called the quadrigeminal plate, because it's made up of 4 caliculi. There's 2 superior and 2 inferior caliculi, and that's why it's called the quadrigeminal plate. But we don't often see those as well on the sagittal view, especially on a regular brain image. You can kind of see here how they've tried to draw the illustration a little bit better so you can see the superior caliculi and the inferior caliculi. But just remember that when you're looking at an axial slice of the brain, especially right through here where you might see the mammillary bodies here, and then the cerebral peduncles and the quadrigeminal plate, and then go back to the brain, you're going to see the cerebral peduncles anterior to the sylvian aqueduct, and then that sylvian aqueduct is anterior but almost sort of within the tectal plate. When you're looking at the axial images, you don't really see a line that goes all the way across left to right. You'll just see sort of a dot in the middle of that area. So we're going to take a look at that here in just a moment. In this view from Netter's, we are looking up from the bottom of the brain. So this is an inferior view, and they've actually taken out the cerebellum and cut the brainstem here. As you can see, we are not seeing any of the cerebellum or the brainstem. And starting in the anterior portion here, so this is the anterior part of the brain and the posterior part of the brain, you can see the optic tracts, and the optic tracts here are just lateral to the pituitary gland. This is the pituitary gland. Posterior to the pituitary gland we have the mammillary bodies, and then posterior to that we have the cerebral peduncles. So these are the connections from the cerebrum to the pons. And as you can see, it has sort of a unique shape. It's sort of like a flower, and it's sort of like petals of a flower. Some people also liken it to a Mickey Mouse. So it kind of has the ears of the Mickey Mouse here. This red nucleus is sort of like the eyes, and then here you have the Sylvian aqueduct, and you can see how small that is. It doesn't go all the way across here behind the pons and the cerebral peduncles as it looks like it does on the sagittal images, but you just have the cerebral aqueduct right in the posterior portion here of the cerebral peduncles. And then behind that is the tectoplate or the quadrigeminal plate. So here we have the superior colliculus of the quadrigeminal plate. So we have the right colliculus and the left colliculus. And then behind that we have the splenium of the corpus callosum. And while this is not a slice, this is the brain as it is with the cerebellum and the brainstem cut and the cerebellum removed. This correlates very nicely to this axial image here, this T2 weighted axial image of the brain. Where starting from the anterior portion, we have the pituitary gland here. We have the mammillary bodies just posterior to that. And then we have the cerebral peduncles, the right and the left cerebral peduncles. And once again, it kind of looks a little bit like Mickey Mouse here. And then we have the Sylvian aqueduct here in the middle. As you would see, fluid is bright, and so you have bright fluid here in the middle of that Mickey Mouse face. And then we have the tectal plate. Some people say those look like the cheeks or part of the nose of Mickey Mouse. So tectal plate or quadrigeminal plate there. And the cerebral peduncles contain the origin of the third and fourth cranial nerves. So I like this view from Netter's here for looking at the brainstem. One of the greatest things to be able to visualize here, I think, is the quadrigeminal plate. And remember that this is a posterior view, so this will be the right and this will be the left. So you have the superior colliculus and the inferior colliculus. So this would be the right and the left superior colliculus and the right and the left inferior colliculus. And that makes it easier to see why it's called the quadrigeminal plate, also called the tectal plate, but now you can actually understand it because there's four little bodies that comprise this quadrigeminal plate. And then you can also see the cerebellum. And they've pulled the cerebellum away on this side, or cut the cerebellum from the brainstem on the left side, but you can see the right lobe of the cerebellum here, and you can see the superior cerebellar peduncle here on the right, and on the left you can actually see the three cerebellar peduncles. So you're going to have three here, the superior, the middle, and the inferior. And the middle is the largest of the cerebellar peduncles, so that's the one that we actually think that we can see well on MRI. When you're looking at them and you say you're seeing the cerebellar peduncles, you're usually seeing the middle one. But taking a look at that, so that's the posterior view. It can be a little bit confusing, but it gives you the idea of the quadrigeminal plate and then also the cerebellar peduncles, which I think is important. And then taking a look at the sagittal view, which will correlate well with our MR images in the next few slides. So let's take a look at the pons first, and the pons is the larger area here of the brainstem, and it connects the midbrain superiorly to the medulla inferiorly. So the pons is inferior to the midbrain and superior to the medulla. Also anteriorly to the pons, and we won't see it here, but we'll see it on the MRI and then in later slides in netters. Anterior to the pons is a shallow groove, and that is for the basilar artery. So the basilar artery runs anterior to the pons. The pons also contains the cranial nerves 5, 6, 7, and 8. The medulla is inferior to the spinal cord. It has the origins of 9 through 12 nerves 9 through 12. And it connects the pons to the spinal cord as well. And then we have the obex here, the opening into the spinal cord, the central canal. And then the cerebellum occupies the posterior fossa. Remember that infratentorial area below the tentorium. And it's attached to the brainstem by 3 pairs of peduncles. So just as the cerebral peduncles connect the cerebrum to the pons, the cerebellar peduncles connect the cerebellum to the brainstem. And there are 3 sets. We saw them up above here: the superior, middle, and inferior cerebellar peduncles. And then we have cerebellar tonsils that are inferior to that, and sometimes on a sagittal image you'll see some of the cerebellar tonsils being pulled down into the brainstem and sort of blocking off that CSF pathway, and usually that's due to some sort of trauma or perhaps a pathology of some sort of tumor. And we have seen that on some MRI images, but these are the cerebellar tonsils here that do get pulled down into the brainstem or into the brain canal sometimes, the brainstem canal sometimes when there's pathology. So taking a look at the cerebellum, there are some superior and inferior views from netters, nothing really from the posterior side. The superior side doesn't have a lot of distinguishing anatomy, but in between the 2 lobes, in between the right lobe and the left lobe, you have the vermis here in between, and that's a connection between the right and left lobes of the cerebellum. From the inferior side, you can see it a little bit more clearly. You can see this vermis, it's a sort of little striated area, and I know that on this image it all looks striated, but when you take a look at it in on axial images, you'll see those striations a little bit more defined in the vermis in between the lobes of the cerebellum on axial slices. And here in this actual slice from netters, where they've taken kind of a good thick slice through the brain, you can see the vermis here in the posterior section, and then again in the anterior section. And then you have the cerebellar peduncles, which are the connections from the cerebellum to the brainstem. And when you take a look at that on the sagittal slice, again, we talked about this a little bit before, but if these cerebellar tonsils hang down into the foramen magnum in the opening for the brainstem there, it can block off the CSF flow. And if it does that, the CSF backs up into the brain, and that's where you get the enlarged lateral ventricles and enlarged ventricles of the brain. So that can cause an issue when you see that in the brain. It may be because the cerebellar tonsils are hanging down. It may be for other reasons, but that's one area to take a look at on your sagittal images. So taking a look at our sagittal midline MRI images, on the left here we have the cerebral peduncles. Remember, the cerebral peduncles are the connections from the brainstem or the pons up to the cerebrum. Make sure you're careful on your spelling on the quizzes and tests for cerebral versus cerebellar. And then the Sylvian aqueduct, or the aqueduct of Sylvius, is posterior to the cerebral peduncles, and then the tectal plate is posterior to the Sylvian aqueduct. And then below that we have the pons, which is over here on this image on the right, sort of an egg-shaped area of the brainstem. And that is inferior to the cerebral peduncles and then superior to the medulla. And the medulla is then inferior to the pons and connects down into the brainstem. And then posterior to all of that, we have the cerebellum. And we have that infratentorial, so below the tentorium. And the tentorium is a separation in between the cerebrum and the cerebellum. So when taking a look at that on axial images, we have an axial T2 here. Both of the images are axial T2s. And on the left image, we have the temporal lobes anteriorly, and then we have the pons in the middle. And remember, anterior to the pons is that basilar artery, and so that is that black dot here, just anterior to the pons, and you can kind of see that groove in the anterior portion of the pons that leaves room for the basilar artery. And part of the reason for that, I'm going to go back a slide just for a moment. Part of the reason for that is we have the clivus here, and that is part of the skull, and it's a bony part of the anatomy. And so the basilar artery is just between that clivus and the pons, so there needs to be a little bit of space there, and that pons has just a little bit of a divot in the anterior portion of it so the basilar artery can go through. And going back to this other slide, so the pons, and then posterior to the pons is the fourth ventricle. And you can see on either side of the fourth ventricle are the cerebellar peduncles. And the cerebellar peduncles connect the cerebellum to the pons and the brainstem. And you're seeing the middle cerebellar peduncles. Once again, those are the ones that are easiest for us to recognize. So we say that we see the middle cerebellar peduncles. And then the cerebellum posteriorly with the vermis here in between the right and the left lobes of the cerebellar hemispheres. And we're at the level of the ears, and at the level of the ears you see the internal auditory canals, also known as the IACs. You may often scan the IACs in MRI, and we'll do some thin slices of those to be able to see those nerves more clearly. Those are the 7th and the 8th cranial nerves. And remember, in the pons, the 5th, 6th, 7th, and 8th nerves come off the pons. And so when you look for that, you'll know that you are, when you see the IAC, you'll know that you're at the level of the pons because the 7th and 8th nerves come off of the pons. And then inferior to that is a medulla. So you see, we no longer see the 7th and 8th nerves, we're just at the very base of those. And in the medulla, the 9th, 10th, 11th, and 12th nerves originate at the medulla. You're still seeing the basilar artery here, and the cerebellar hemispheres, the right and the left, and cerebellar vermis. Now we have sagittal T1 weighted images, MRI images. We have the pons here, and the cerebral peduncles, the medulla, and the cerebellum here, the tectal plate, and the tentorium as well. And then if you go a little bit lateral to that, so just a little bit off center, you can see the cerebellar peduncles here, and then you're just starting to get into the cerebral peduncles here on the a little bit superior to that. So you're not able to see them quite as well because we're not as far lateral, but if I go too far lateral, you won't be able to see the cerebellar peduncles. But this is so that you can see the distance in between them, or be able to see where they are located in the brain on an off-sagittal image. So the cerebellar peduncles are here, the connection in between the cerebellum and the pons, or the brainstem, and then in between the brainstem and the cerebrum are the cerebral peduncles. And just a few more images before we move on to other areas of the brain. Going from posterior to anterior, so this slice is the most posterior, moving more anterior as we go from left to right. You have the cerebellum here and the tentorium on either side, and you've got the vermis in the middle. So I wanted to show you the vermis in a coronal plane as well. As you move more anterior to that, you start to get into the brainstem. You see the cerebellum and the cerebellar tonsils here on either side. And then you see the cerebellar peduncles. So you see that connection from the cerebellum to the brainstem here, cerebellar peduncles. This image correlates very nicely with that posterior view from Netter's that we had. So when you take a look at those two side by side, that's very helpful. And then you see the fourth ventricle here. And then if you move more anterior than that, so that you are out of the fourth ventricle, you can see the pons. So you can see how it extends a little bit laterally as well. When you see the sagittal image, you can see it extend anteriorly, but it also does extend laterally as well. And then you see the medulla inferior to that, so much thinner portion of the brainstem inferior to the pons. And then superior to the pons, remember, are the cerebral peduncles. I'm having a hard time trying to say those two consistently throughout this class and not say them incorrectly, but the cerebral peduncles in between the cerebrum and the pons. So you've got the cerebral peduncles here, and that's that connection. And then we'll move on to the next lecture.